Hello, Mr. Ran, are you right?
Yeah.
Okay, so today we're given an array of numbers, a list of numbers, and we want to find out a meter index. So let's define this meter index, okay? Meter index. What's meter index?
-1, I think.
No? So meter index, you split the array into two halves, right? The left and the most. If the sum of left, yeah, we use this. If the sum of left, yeah, this meter index, let's call it M, okay? We sum the meter index of what? Sum, yeah, sum of S. This is array S up to meter index M, yeah. Meter index M is equals to the sum of the S M plus 1, okay? M plus from M plus 1 to the N. So can you find if there are multiple meter index, we just pick the leftmost one. Okay, this is easy. This is easy. Which index? Two? What is that? 0, 1, 2. So you choose this as meter index. What's the sum of these? That's 5. What's the sum of this? This 12. This does not equal.
Oh.
What's this?
Wait.
Yeah? What's the meter index? Come on. Define. Given this
Let me think.
Come on. It's right next to it.
8.
So meter index 0, 1, 2, 3. Okay. So I pick this as a meter index. What's the sum of this one?
Ryan's supposed to say 3, not 8.
Yeah. That's fine. What's the meter index 3? Yeah.
What's
What's the sum of the left part? 2 plus 3 plus minus 1 is 4. And what's the rightmost part? 4. You can choose the meter index as the first one. In this case, the left sum will be 0, right? If you choose the meter index, the last one, the sum of the right part is 0. Yeah, remember this is the sum, yeah? Yeah? This is the sum symbol, okay? And in Python we can use this. Any idea? Easy, that should be very easy, yeah?
Brute forcing.
Brute forcing, how do we brute force?
Checking every number.
Checking every index from the left to the right, right? Yeah?
Because
Alright?
you don't understand recursion.
Yeah.
Read the structure again.
Okay, so can we implement this together, yeah, with the brute forcing from the left to the right? And can somebody give me the eraser, please? Oh, there.
Yeah!
Okay, that's it. Thank you.
We're sidekicks.
Define meter index. Yeah, meter index. We have list nums. Okay, so now we need to. What's the n? N equals length num, right? The length.
Boom, yeah.
Okay, so now what should we do? We should go for the let's say for I in range what? Range what? Come on.
N.
Range n. Come on. And now what's the sum of the left part? The left part will be L, yeah? Will be sum. Yeah, we use this function. Sum. In Python, sum, yeah? And then the left part, nums what? Nums up to what?
I.
Up to I, right?
Plus 1.
Up to I plus 1, right? Is it true?
I don't know.
What?
No. Normally you do
No? Normally I do I plus 1. But in this case, do I need to I plus 1?
No.
Okay, so it's sum. If this is empty array, if I is 0, it will be 0, okay? And the right part will be what? Sum. Sum what?
I got 1 this time.
Yeah. And
I'm genius.
Okay, so can you tell me why we skip the I? Why we skip the nums I?
Oh, because
I is the what?
the one which is
I is the middle, right?
yeah.
If L equal I, then we return what? Return what? Come on. Return what? Which index is the middle index?
8.
We are going from the I from the 0, yeah?
So,
I, yeah?
I said I.
Okay, if there is no index, we return -1, okay? I forgot to mention this. Okay, this is a tricky one. What's the time complexity? This
N cubic. No. N square.
And why is N square?
Oh, I'm guessing here and here.
This is N, but here is another N, right? Yeah? O-N, right? Am I right?
Oh, wait, no.
O-N is O-N square. But this L and R is O-N. N plus N. It's like that, yeah?
O n n plus.
Yeah?
So
how do you simplify it? O
n
2
cubic.
times n. How is that O n cubic? N plus n, 2n.
Cubic.
No, I said n plus n. It's not n times n. Come on.
Okay.
So O n 2 times n squared. So I drop the constant. Yeah, we drop the constant. O
I
n.
said n square.
Yeah, but you need to understand how we're getting this. Okay.
Ow.
Okay. So the problem of this approach is this sum, right? Yeah. It's taking time, right? Do we need to actually do this? I mean,
You can.
can we improve this?
Yes.
So how can we improve this? Come on. If this array, right? Like 1, 2, a minus 1, 2, 3, 4.
5, 6.
Okay, so if this one, if we can do this one time, and then it will be a sum of everything, all the numbers, right? We can do this, adding all the numbers, yeah, right?
Yeah.
And then if we keep doing it, keep adding this, if we add this, so we know what? We know this part, and we can also use the s minus this part will be the sum of this part.
I
Yeah?
don't think it's possible.
Why is that? Yeah, I know. I'm just saying that we can accumulate the sum of the left part, the sum of the left part. Yeah, we can accumulate the sum of left part, I plus 1, and then we use this, I don't know, bigger s minus smaller s, then that will be the sum of the rightmost part, right? Got it? It will be similar as the prefix sum, remember? You know the prefix sum? We talked about this prefix sum, remember? Yesterday, 1, 2, 3, 4, 5, 6, 7. What's the sum of these bit?
It is
What's-
12.
12, yes. But
Because 1,
what's
2,
the time
5.
complexity if you're just adding the sum of numbers
Okay.
for ON? But can we do better?
Yeah, 01.
And how do we do better?
And we just do 1 to 5 and just subtract 1.
Yeah, that's prefix sum. We calculate this into this accumulate function. Yeah, remember we accumulate function, accumulate, and then that will give us what? 1, 3, what? 1, 3, what? What's next?
1, 3, 6, 10,
Uh-huh.
15.
21, 28. Okay. So what's the sum of this bit? Is it the same as the sum of these 5 numbers, which is 15, right? And I need to minus the first 2 numbers, right? Yeah. The sum of these the numbers from 3, 4, 5 is the sum of the first 5 numbers subtract the first 2 numbers. In this case, is 3. Is 15 minus 3 equals 12. Look, we're just looking up the numbers and we just subtract 1. Is 12. It's faster. It's the same. It's a similar. So we can do this. Okay. Find mid index. You know this question, yeah? This question is the first question in the LeetCode context today. Yeah. Yeah, it's pretty new.
What do you mean?
There's a contest, programming contest every 2 weeks. You know, every week or possibly, yeah, every week, yeah.
Yeah.
This is the first question. Okay, so now sum. We use the sum. How do we calculate the sum of all the numbers? Use which function? Which function? Come on.
Sum.
S-U-N, yeah. Nums. And then n will be what? N will be length. Do we need the n? Probably we don't need the n. Let's do it. We use the c to compute the current sum equals 0. For what? For what? For do you still remember the enumerate function? Remember we talked about the enumerate function yesterday, yeah? What's the enumerate of this ABC? Come on, what does it return? What's the enumerate function?
A, B, C.
And then that's here. Enumerate.
1.
0, 1, 2.
0, 1, 2.
Okay. So for I, let's say x in enumerate numbers. First of all, if we check if the sum minus the x minus c equal what? Look, this is the array, yeah? This is the array. And now I know that the whole sum is s. And now I'm iterating the x is the middle element, right? If I minus this element, and I minus the previous one, so what's next? What's this part? It's this part, right? The right part, yeah? Yeah? Look, the overall is S. Look at me. The X current, the middle element is X. Yeah? And I subtract X. And I subtract this bit is C. And what should we get? What should we get? The overall is S. I subtract X is middle. I subtract C, which is the sum up to X.
The other half.
And then the other half, right? So what should we check the other half? Equals what? Equals what?
Equals C and
Yeah, C, let's say. If we then know return what? Return what? What's the index? What's the index? Return I, right? That's it. And what's this? And yeah, and now what should we do now? Return what? Return minus 1 here. Minus 1, that's no answer. Come on.
Oh yes, it is.
That's no answer, okay? So, okay, there's one thing missing is there's C. We need to update the C. C plus equals what? C plus equals what?
C plus equal 1
1?
plus.
C plus equal what? Come on. What's I? What's I?
Index.
Index. What's X?
X.
Yeah, the value, yes. The sum up to. So look, I just draw this picture, remember, the whole sum is S. And now I'm at X, yeah? This is X, this is the index I. Yeah, come on. The index I points to X. And then I sum C is the value up to X, yeah? Okay, because I put it after the if, so it's can you listen to me? Put it here. So here is C. So what this should be the C, right? So if it's the C, if the left part is equals to the right part, right? Then we return the index I, and then in the next iteration we expand the C, include the C to X, and then we move the X to one position to the right. Okay? What's the time complexity? What's the time complexity? Eric,
Yeah.
what's the time complexity? What you doing? Owen. Yeah, Owen. Owen.
Oh, I think
Yeah, why is it Owen? Why is Owen? Why is Owen? Come on.
Because fully.
Yeah, I know we just checking it. We accumulate the answer here, right? Yeah, got it.
Yeah.
Okay, can you write this? Can you write this? If you know, then I give it back to you. Come on, Eric, your turn. Come on. If what? Look, this is S.
S minus value.
This is C. Okay, this is I. Right? Minus what? Minus what?
X.
And minus what part?
C.
Yeah, and equals to what?
S.
Equals what part? This is the left, this is the right. We want to find the index, which is the left part equals the right part. So what equals that?
Pen.
Equals what? What's
What's
this bit?
C.
Yeah.
Dot.
Come.
I can have it now.
Okay, good
Dot,
job.
dot.
What's the space complexity? Are we using any space? Are we using any space?
Look.
No. Yeah. This is another ON, right? This is another ON. Okay. Okay. That's it for today. For today. Space complexity is a 1. Okay.
Bye bye.
Bye bye. Bye bye.